Hi guys, ako nga pala si Remy Magbo from IT2102 and today I will discuss and I will do the activities in chapter 2 in chapter 6 in CNA 1 the entitled network layer. The first one is the summary or the summary. Network application and services on one end device can communicate with application and services running one another end device. How is the data communicated across the network in an efficient way? We're going to tackle it. First one, the characteristics of IP. IP was designed as protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system network. The first one is the frame, source, IP header, the data. What is connectionless? It is a no connection with the destination is established before sending data packets. The best efforts is that IP inherently unreliable because the packet delivery is not guaranteed. The media independent. It is the operation is independent of the medium. For example, is the copper, fiber optic, or wireless carrying the data. IP connectionless. It is the meaning that not dedicated end-to-end communication connection is created before the data is sent. Is in the figure shows that the connectionless communication is conceptualized similar to sending a letter through to someone without notifying the recipient in advance. The second one is the best effort. This is the best effort. It's an unreliable network layer protocol. IP does not guarantee that all sent packets will be received. In the other way, it means that have not the capability to manage and recover from delivered or corrupted packets. This is the media independent. The IP packets can travel over different media. For example, in the figure, the IP packets can be communicated as electronic signals over the copper cable, optic fiber, and the copper serial. It is wirelessly as radio signals. It is a responsibility of the OSI data link layer to take an IP packet and prepare for its transmission over the communication medium. This means that the transport of IP packets is not limited to any particular medium. We're going to have an activity, the IP characteristics, the instruction with each IP characteristics, the connectionless, best effort, or media independent. First one is the will send. This is the characteristic, the delivery method like connectionless, best effort, and media independent. We're going to click it and drag and click to the designated method. Will send a packet even if destination host is not able to receive it. It is a connectionless. Does not a guarantee that the packets will be delivered fully with errors. It is the best effort. Will adjust the size of the packet sent depending on what type of network access we use. It is a media independent. Fiber optics, cabling, satellites, and wireless can also be to route the same packet. It is dependent. Packets delivery is not guaranteed. It is a best effort. No contact is made with the destination. It's in connectionless. It is a no connection or no contact. It's all correct. Okay. Going to second activity. The IPv4 packet header. It is the IPv4 packet header. Header includes significant fields. The first one is the version that contains a 4-bit binary value set to 0100 that identifies this is an IP version for packets. Differentiated service or this services DS. This is the 8-bit field used to determine the priority of each packets, and the time to live contains of 8-bit binary value that is used to limit the lifetime of packets. The protocol, it is the 8-bit binary value indicates the payload type that the packet is carrying. The next is the source and the destination. It is the 32-bit and the binary, and it is the address of the packet. So this is the activity, the part 1, IPv4 header fields, the version, and time to live, source IP address, the differentiated services protocol, destination. We're going to click here and click to the designated location. First one is identify the IP address of sending host. It is source IP address. Identifies the priority of each packet. It is the differentiated services. Identifies the upper layer. It is the protocol. Identifies the IP receipt. It is the destination IP address. Commonly referred as hop count. It is time to live. This is the always set to 0100 for IPv4. It is the version. Okay, proceed to the another one. The packets forwarding decision, the remote networks, the directly connected routes, remote routes, and default routes. Mm, The router routing table. It is the in the figure one. In addition to providing routing information for directly connected network and remote networks. When the packets arrive at the router interface, the router examines the packet's header to determine the destination network. This is the route source, identifies how the network was learned by the router. The second one is the destination network that identifies the destination network and how it was learned. And the outgoing interface that identifies the exit interface to use to forward a packet toward the final destination. The C equal is the identify the automatically created when interface configured with IP address activated. L is identifies the local interface. Now we're going to have an activity, the identify elements of router routing table entry. The instruction, a partial router routing table entry is shown. Each section of entry is identified by a circled letter above it. Select the correct routing table entry section for each output. This is A, letter, this is the letter B, the address, and the C, D, E, and the F. The first one is the elapsed time since the network was discovered. It is letter E because this is the time. The administrative distance source and metric to reach the remote network, it is a C because of the source. How the network was learned by the router, it is an A because and the 4 shows the destination network, it is a B. The next hop IP address to reach the remote network, it is a D. And last, the outgoing interface on the router to reach the destination network, it is the gigabit internet. Let's check. It's all correct. Let's proceed to the next. This is the IPv6 header description. We're going to have the version, traffic class, flow level, payload length, next header, hop limit. This is the header description. When this value reaches 0, it is a hop limit. It's always set to this is version. Identifies the application. This is the next header. Identifies the size of the data portion of packets the payload. To suggest all packets, it is flow label. Classifies packets. It is okay. That's correct. Proceed to the next activity. Connecting a router. We're going to this is the enhanced high-speed WAN interface card or the EHWIC. This is the compact flash slots. This is the auxiliary or the AUX, the gigabit Ethernet, console ports. This is the console ports. And last is the USB or the provides additional storage space similar to flash or the flash drive. This is the LAN interface. The connection on the Cisco router can be grouped into two categories. The first one is the in-band routers interface, and the second one is the managed port. Now, we're going to have an activity, the description or the instruction of the router's function and hardware parts are provided in the table. Drag each router component's name to its functional description. First one is the connects routers to extend network usually over a large distance. From the word large distance, the WAN interface. A way to remotely access the CLI across a network interface. Remotely access, it is a telnet. Connects computers, switches, and routers for internal networking, it is a LAN. A local port, which uses USB or low-speed serial connection to manage network, it is a console port. A port to manage it's an AUX. Let's check. It's all correct. Let's proceed to the last activity. This is the router boot up process. First one is the performing post and load bootstrap, locating and load Cisco in the figure 3, is and locating and loading the configuration file. The first one is the performing post and load bootstrap. It's the program is copied from ROM into RAM. The main task of the bootstrap program is to locate the Cisco IOS and load it into RAM. And the other one is locating. This is typically stored in a flash memory and is copied into RAM for execution by the CPU. The locating, it copies the startup configuration file from NVRAM into RAM. Yeah. This is show the version of the output. Okay, this is the activity that we're going to do. Instruction. Drag each up step of the left to appropriate field in the table of the right to show the router boot's process order. This is the router process, the step 1, 2, 3, and 4. We're going to drag it from there. So we're going to perform post hardware and then load the iOS. Now, load the bootstrap and then load the iOS. Load the configuration file from the flash. It's all it's correct. Okay, this the summary or of this. Chapter 6 is the network layer provides services that allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer is used for basic process. The first one is the IP addressing for end devices, encapsulations, routing, and the encapsulations.